In the next 50 years, the global population is predicted to rise by a third to 9 billion. Half the world already lives in urban areas. Our cities cover just 2% of land, but consume a staggering 75% of resources and discharge 75% of all waste.
Over the last century, human numbers have grown fourfold, whereas urban populations have grown 15-fold, and today, half the world's population is actually urban.
In other words, we'll need twice as many cities as we have today.
Perhaps we're evolving into something like a social animal parallel with the ant or the termite, and our cities will become our whole existence.
But pollution from cities is causing illness, global warming, extreme weather, and destroying ozone.
That's happening now. The fact of the matter is, pollution from power generation, whether it's in a car, or whether it's a power generating station, or whether it's an industrial application or a ship, is killing us. We must be able to change the technology.
Unless we find new forms of construction, energy, and transport, in the 21st century, will our planet cope? Globalization has brought us greater awareness of ecological devastation around the world. But how can we accurately monitor the damage from chemical poisons, CFCs, and carcinogens? One invention actually led to the Green Revolution.
That is an electron capture detector, the gadget that started the environmental movement. There's two pipes. There's one pipe where my finger is, and another pipe there. Gas comes into here, and any pesticides or things are detected inside that chamber. Within a few years, scientists were using it to discover pesticide residues right across the world. They found them in the fat of penguins in Antarctica and the milk of nursing mothers in Finland. That shows how big was its global distribution.
Lovelock's device was also the first to monitor CFCs, or chlorofluorocarbons, which are contributing to the problem of global warming.
It was equally important there in first discovering those gases in the atmosphere and finding that they were accumulating as we continuously use them in our spray cans and refrigerators.
Lovelock realized that pollution on one side of the planet can affect ecology across the world in other countries. He now sees our planet operating as one system. Named after the Greek goddess of the earth, Gaia theory links the whole world together like a single self-regulating organism.
My first thoughts on Gaia, the whole system of the earth, life and the rocks and so on acting as one, began in the 1960s when I was working for NASA.
Lights on, forward.
Looking for life on Mars was what led me to look at our own atmosphere in an holistic way.
But pollution is destroying Earth's natural systems. We are reaching crisis point. If we don't look after the world, we can pollute it to the point that life will die out.
Where you have a single system, any changes such as we are doing, increasing the greenhouse gas of the atmosphere, affects the whole system, not just parts of it. Some organisms will benefit from this change, others will be damaged by it. We, as the cause of it, are likely to be amongst those that are damaged by it.
Over the next century, we'll create twice as many cities. This also means doubling the greenhouse gases and other pollutants entering our atmosphere. Sustainability means thinking about the future environmental consequences caused by developing now. For the Earth to survive, we need sustainable solutions based on natural systems. New forms of buildings, transport, and power are essential to stop the long-term damage. A primary concern is the use of raw materials, which take vast amounts of energy to produce.
Currently, we use 6 tons of building materials per person per year. That is too much. We have to find more sustainable methods of constructing the buildings and the cities in which we live.
Architecture uses about 50%, buildings use about 50% of all energy. 25% is due to traffic, which is in a sense related to the whole urban design and, of course, and cities. And the other 25% is basically industry and agriculture. So architecture is a critical part of the whole question of a sustainable world.
Standing derelict on the edge of the Thames, Battersea Power Station once burnt tons of fossil fuels, polluting the atmosphere. Ironically, it's now part of this new movement to save energy by recycling.
This building is it's sustainable because it's here. It's a sustainable operation. It's here as an old power station, which is in a sense being recycled. So all this brickwork will be retained in the same way that Tate Modern recycled the building. In here we're going to have completely new internal structure supporting a great internal activity space for ballet and three-dimensional events of all kinds, enormous numbers of restaurants and shops and all that kind of thing. People are much more prepared now to mix new with old, to use, for instance, a very sophisticated structure inside what is a fairly straightforward brick building like this. And I think it's the marrying of the two which works rather well.
Buildings should be recycled. They have a lifespan. They should be used for many more things. We're working in two ways. One is to reuse buildings that are existing. There are 1.3 million empty buildings in England alone. And also when we design new buildings to make sure that they can be reused for a different function.
Recycling old structures and incorporating flexible design into new buildings saves energy and resources.
Sustainability is as much about heritage as it is about the future. Lloyd's have a great history. They were established around a coffee house 300 years ago. They're very proud of the history. As clients, they said to us, we want a building that lasts well into the next century. We're not in the building business. We've had to demolish a building every 20 years, basically, within this century. Not only is tremendous upheaval, to the work itself, but tremendous waste of material.
The reuse of the Lloyd's building was taken into account at the design stage, so that when it is no longer used as a trading floor, it can be used for other purposes. So
long life, loose fit, which means flexibility to adapt, because you don't ever know what's going to happen. A building which you build can be a university 1 year, offices another, and you could be living in it as housing. Another question is materials that will last well. All the materials you see around Lloyd's are natural materials. So you see a lot of stainless steel, which has long life basically, a lot of concrete, a lot of glass. And then in terms of low energy, what is probably unique to Lloyd's is that there's triple glass. This means the glass is always a mediator in temperature between the cold and the warm, whether it's winter cold outside or summer hot. The glass itself is a mediator. It's very energy efficient. It also allows you to be comfortable when you get close to glass.
Another practical characteristic of Rogers' designs is incorporating services onto the outside of buildings. Features like electrical components or lifts have a short lifespan. So rather than pull whole structures to pieces for upgrading, parts can be removed more easily, minimizing use of materials and energy.
The classical concept of a building was something that was perfect and nothing could be changed. That's gone.
Rogers' latest project for Lloyd's once again mixes heritage and high-tech, combining original buildings with new energy-efficient designs.
Lloyd's Register of Shipping, which has just been completed, has a system of light-sensitive louvers. When the sun is out, the louvers close down. When the sun is off, the louvers open.
Louvers like these allow flexible use of the sun's light and heat. Not only do buildings take a lot of energy and materials to construct, they also use lots more during the course of their working lives. Reducing air conditioning and electric lighting means cutting power consumption, Concern for our environment is challenging all designers to incorporate energy-conscious features.
Suddenly architects have come to realize that they are not only responsible for buildings and structures per se, that they are also responsible for the environmental impacts of those structures in terms of their energy use, in terms of their use of materials as they're built and so on. Leading architects in this country, such as Richard Rogers and Nicholas Grimshaw, are really pioneering a new kind of more sustainable architecture, and I think that has global implications because these companies don't just work in the UK, they have practices in Tokyo and Berlin, wherever else.
If cities operate like living organisms, then roads are like arteries, delivering supplies, services and people. But it's not a healthy system. Traffic is the fastest growing contributor to climate change, and thousands die every year from long-term exposure to traffic air pollution.
Cars is no good sort of thinking, well, they just are useful from going A to B. They're actually polluting elements. If we keep on polluting the world, then we will not be able to either use cars at one end of the situation, for example, or we have to change the technology of the cars.
Will energy from the space age hold the key to cleaner, quieter, and even cheaper transport? Fuel cells used in rockets are now powering the vehicles of the future.
The first time it was used was in the Apollo space capsules. Francis Bacon was the inventor of the modern fuel cell. He actually went to NASA from the UK and developed their entire systems for fuel cells in space. He put them in space, we put them in vans, not quite so romantic, but a lot more practical. A fuel cell is an electrochemical device. It works in a very similar manner to electrolysis, which you probably learned very early in your science lessons. That is where if you put an anode and a cathode in a beaker of water and electricity through them, it'll generate hydrogen and oxygen from the water. If you reverse that process, what you get is electricity and water. And that's what a fuel cell is. Makes water and electricity by the application of hydrogen and oxygen. Hydrogen contains no carbon. If you burn carbon, you end up with CO2, carbon dioxide. CO2 is very good to go in Coca-Cola, but if you put it in the atmosphere, it'll kill you because it's the main contributor to global warming. When you use your fuel cells and you put hydrogen in it, the only thing that comes out is energy, and that energy is clean energy.
I think we will see the first large quantities of fuel cell cars driving around in our cities in 2 or 3 years' time.
As well as powering cars and vans, fuel cells will also generate electricity for industry, domestic power, and even boats. Z-Tech is making applications in all areas. The most recent research adapted a London taxi, replacing the old diesel engine with a new one using hydrogen.
If you ran fuel cell-powered taxis in a city like London, or New York, or Paris, the reduction of pollutants would be of the order of 25%. And the cost of running it on hydrogen are about 1/3 the cost of gasoline or diesel. We're looking now at buses to be able to see how we can retrofit existing buses, for example, double-decker London Route Masters, to be able to provide clean, efficient, powerful buses at the same price as it would cost to renew them. Fuel cell technology is the energy of today, and it will be applied tomorrow.
The faster that we begin to invest in carbon neutral technologies, specifically including renewable energy, the more competitive we will be in international markets, the more technology we'll have which is relevant to the specific demands of the new millennium.
The world is already consuming an estimated 80 million kilowatt hours of energy every year. 80% of this causes pollution. A sustainable future needs clean, renewable energy on a massive scale.
Although, on the one hand, energy was absolutely central to the development of any modern society, the path that we were on in general was unsustainable. You couldn't keep providing energy the way we are and see to the remaining 5 billion people on this planet if we didn't change something. And so it became obvious that in time we'd have to go beyond petroleum. Our societies run on energy. Nothing happens. The clothes you wear, the food you eat, the movements you take, the industries we work for, all of them are founded on energy. But we can't provide the sort of energy that we've been using to this point and maintain the environment.
Enough energy to meet all our needs falls on the surface of the planet every day. Amazingly, it's also clean, renewable, and free.
Solar power, photovoltaics, that's translation of sunlight into electricity, takes energy in the form of photons and turns it into energy in the form of electrons. And it does that through semiconductors.
Photovoltaic cells are, quite simply, one of the most brilliant human inventions ever. They reproduce the action of trees, they take sunlight and turn it into specifically electrical energy.
Large automated factories for producing photovoltaic panels are being financed by companies like BP and Shell. This is becoming mainstream. It's no longer a weird and wonderful thing only for satellites or calculators.
In theory, there's enough energy coming out of the sun to provide us with everything we'd always want. The challenge, of course, is the technology and collecting it. We're actually experimenting all around the world with these. We powered the Olympic Village, for instance, was solar powered by ourselves. There are 3,000 communities in the Philippines who are supported by our solar powered technologies. The same in India, the same in Asia, in Spain, in the USA.
It would be brilliant if politicians and statesmen in the third world embraced something like solar power in a single jump and leapfrogged the mistakes of the West, if you like.
In remote villages in places like India, or indeed in scattered remote settlements in the United States, the use of photovoltaic technology is already fully cost-effective because it doesn't make sense to connect those settlements up to the grid.
And you see this with mobile phones in China, for instance. There's no need to have a copper wire grid throughout China connecting to 1.2 billion people. You just put in mobile phones. Solar power can do the same for you. It's really effective as a distributed system. I think when you look at the challenge of sustainability and how we're going to bring it about, you see that it's incredibly complex. It's about changing the way we do everything. And so we're only going to make that shift if everybody participates. So I think some things will have to be led by government, other things by industry and the commercial world, but ultimately, until every individual makes the change in their own minds, we're not going to drive it or shift it at the pace that it needs to be shifted at.
But how practical will it be for individuals to change to more sustainable lifestyles?
Hope House is a prototype family home. It's built very economically using local materials. It has the ability to be environmentally upgraded over time as we can afford new features such as photovoltaic cells and solar hot water panels.
Hope House faces south, maximising free solar heat and light. Sustainable local building materials like wood and concrete store heat, releasing it slowly later. Heating requirements can be reduced to as little as 10% of a conventional home.
The rest of the house is well insulated and specifically is thermally zoned, enabling only the living room to stay at comfortable temperatures all winter.
Hope House is now the blueprint for BedZ, the first large-scale zero-emissions housing development. 100 energy-efficient homes will have on-site work and leisure facilities. Just like Hope House, the new development will run shared electric vehicles. For the first time, solar panels will store enough electricity in BedZ to power 40 electric cars. Environmental awareness is worthwhile, but too often it's seen as difficult and costly to put into practice.
BedZ has shown that it is possible to do buildings that are sustainable and are not too expensive and can be used. I think there will be many others that will follow.
Bill Dunster and his colleagues are to be congratulated in starting a revolution in housing development.
With Z thinking, it's a way of future-proofing So as global warming starts to create more and more of an effect, this lifestyle and the technologies that create it will become more and more attractive.
Pollution is changing our climate and destroying ecological systems. In future, some architects believe we may even try to control our environment by recreating the outside world inside. It sounds like science fiction, but Nicholas Grimshaw is already shaping that vision in Cornwall.
Eden will be the largest greenhouse in the world, there's no doubt about that. And we've deliberately set out to make it as environmentally friendly and green in every sense as it's possible to be.
The Eden Project's building a living theatre of plants and people, looking at all the ways we use plants and our need to conserve plants.
Very few people have ever seen a real rainforest. What we're doing is creating a piece of one in Eden so that people can see what it's like.
Eden is being created by recycling a disused clay pit. The whole site is the size of 35 soccer pitches. 2 enormous greenhouse domes known as biomes are being sustainably constructed. High enough to stack 11 double-decker buses on top of each other, this vast space will provide a showcase for plants from all over the world.
The basic form of structure at Eden is this geodesic steel structure of hexagons, which are up to 15 meters across. And inside those are pillows.
The pillows are made of triple glazed sheet Teflon. As well as being strong, lightweight and transparent to UV light, it's also recyclable. We have an abseiling crew who look after the building and have put these cushions into place. A very important aspect of Eden is that we collect all the water falling on the site, and we use that for watering all the plants. For every other use you need water except drinking. The whole building is a sort of living, breathing organism, as I see it.
Eden's about making connections between plants, animals, people, the natural environment, and how they're totally interdependent with each other.
I would like to think people would leave Eden and that they would be left with thoughts about sustainability and that they could do it. They could do something with solar gain, they could do something with their solar water heating, they could do something with recycling the waste products from the house. They could do something by using recycled building materials when they change their houses or extend them.
New technologies are helping us shift to a sustainable future. Will things only just being imagined have a role to play?
Obviously, there are very exciting possibilities in terms of the synergy between, if you like, electronics, microchips, and materials in creating responsive facades of all kinds. Perhaps furniture that automatically shapes itself to whoever's using it.
I sometimes think of materials which breathe, which change colour, which renew themselves, maybe, or even which are naturally growing materials.
Things like thinking buildings who think for themselves and possibly for us, for materials that react to temperature. I think these are all going to make a big difference in how we can design for sustainability.
What I'd like to be able to see is the time when a Maasai tribesman can go into his hut, turn on a television powered by a fuel cell that he can generate his own fuel for. The end of the economic slavery of power, and also the end of pollution.
All of that, I think, is no longer just an issue of imagination, but something that is very palpable, because people want a sustainable future, and I think these ideas put together will offer us one.
New forms of architecture, energy and transport will all benefit the planet as a whole. But we now need to think not only about where we'll live in future, but how. Each of us must make the personal decision. Will we be part of the problem or the solution?
Unless we actually design the futures that we want, we're going to get futures that we don't want. And so all of us have to think about how we do this. All of us has to participate in both changing our behavior and in bringing new technologies to the fore. Because if we don't, then the future is not sustainable.